Hi everyone, welcome to our tutorial on how to create a dynamic size page swipe control like this in Godot 4.5. In this tutorial, we will show you how to set up the scene for the page swiper, how to implement the functionality, how to create an example button to use in the page swiper, and we will show you some use cases on how the page swiper can be utilized. Great, so let's get started. The scene is made up of four main elements. First, a VBox container that aligns the panel together with the page display. Then we have the scroll container, which handles the swipe animation when the user switches pages. And next is the grid container, and it holds all the control elements that appear inside the swipe panel. And finally, there is the page display, which shows the user their current page. So here is the page display scene. This scene is very simple in structure. The root node has a script that exposes two variables: the total number of pages and the currently active page. For the page indicators, we are using two textures. One texture represents the active page, and the other is used for all non-active pages. All of these indicators are arranged inside an HBox container with a centered alignment. So after we set everything up, go grab yourself a cup of coffee and let's dive into the code. So let's start with the script for the page display control. Here you can see a function called reload textures. This function first clears all elements inside the HBox container and then reloads the correct textures based on the currently active page. In this example, I've also scaled down the textures to fit the layout. It's important to set the custom minimum size for both the textures and the HBox container. Otherwise, nothing will actually be visible. Now let's take a look into the swipe panel script, which is attached to the scene's root node. So the script exports several values: swipe tolerance, swipe duration, columns per page, rows, and the total page count. And these properties are used to calculate the size of the swipe panel and ensure everything fits correctly. So the first thing we need is swipe detection. We do this in the input function by checking for inputs events screen drag. Before processing a swipe, we also check if the panel is currently changing pages. Since we use a tween for the swipe animation, we make sure it's not running, otherwise no swipe will be triggered. If the event is a screen drag and the panel can be swiped, we read the relative movement vector and compare it to our swipe tolerance. Once the movement exceeds the tolerance, we call either swipe left or swipe right. So that's how to change the displayed page after a swipe. The swipe function first reads the page display control's active page property to make sure the next page index is valid. The page index must be no less than 0 and must not exceed the total number of pages. If the next page is valid, the swipe animation starts and the page changes. Since the active page has changed, we also need to reload the textures in the page display control to update the page indicators. Okay, now onto the animation itself. The scroll container is responsible for the swipe animation. The key part is setting the scroll horizontal property to the correct position for the new page. The new value of the active page in the page display control determines this position. First, we check if the grid container is empty. If it is, then there's nothing to do. Next, we calculate the pixel offset for the top left corner of the new page. We do this by adding up the sizes of the grid container's child elements plus the grid separation constant, and then multiply the results by the columns per page property and the active page index. However, this offset isn't the final scroll horizontal value. To get the correct value, we use the clamp function. This gives us the target position for the scroll horizontal property. And finally, we create a new tween and pass the scroll container the property name scroll horizontal, the target value, and the swipe duration property from the swipe panel as parameters. And voila, that's our new swipe animation. The final part is making the swipe panel dynamically sized. In this function, any control can be added to the grid container inside the scroll container. Based on the size of the added elements, a new minimum size for the swipe panel is calculated and applied. In this way, the swipe panel automatically adjusts its size depending on the elements you add. Now that the swipe panel is ready, we want to fill it with our fancy content. For this example, we create a new scene with a button as the root node. The button has a simple script that reacts to the pressed event. As you can see, the emitted signal takes the button itself as parameter when it is pressed. In other situations, you might want the signal to pass additional data depending on your needs. In our main scene, we add the swipe panel scene as a node and attach a small script to the root control node. For this example, we want to add 160 elements in 5 pages to the panel. To make this work, we adjust the swipe panel properties so it can load the 160 buttons. In the root node script, we fill the swipe panel with the buttons we created earlier. This happens in the ready function. We just instantiate the buttons and use the add element function provided from the swipe panel. Now we press the play button and that's it. We get a clean, dynamically sized page swiper that adjusts itself to whatever we add. Great, so now let me show you a few extra results from our upcoming game, Galaxy Conquest Online. In Galaxy Conquest Online, there will be an item shop, and we use the swipe panel to paginate the shop's content. Another example is our ship customizer, where we use the swipe panel to browse through the different ship paths. This example project is hosted on GitHub. The link is in the description below. If you enjoyed this video, make sure to leave a like and hit subscribe. Your support helps a lot, and thank you so much for watching.